Hello, good evening, happy Thursday. Yeah, we it's like this like we came, we saw, and we conquered kind of moment. Oh, Eureka moment. We got it. Okay. Oh, it was. I will share it with you, but I've been thinking like after recording and this morning, and we got it, ladies and gentlemen. We got the infinity down. Okay. Now infinity algebra, well, it's only beginning, but we made a major step forward. Okay, it's a big, quite a big theoretical achievement that we accomplished here. Okay, so I share it with you. So it's like this. Okay, in chemistry, in chemistry, what we have what's called absolute zero, right? Kelvin scale, where all the molecules stops vibrating, like zero energy, absolute zero. Yeah, negative 273.5, something like that, degrees Celsius. That's absolute zero. And in mathematics, we have also absolute zero. Okay, which is constant. It's not a variable. And also we have fake zero, fake, like zero wannabe, or like imitation zero. Okay, we call in mathematics we call that infinitesimality. It's a function. It's a variable. It's never zero, but it approaches zero. Get closer to add infinitum to infinity. Okay, it never goes to become zero, but it becomes very close to zero, closer and closer as time goes by. Like y equal 1 over x. Okay, x is, say, is time variable. Y is equal to 1 over t. Okay, yeah, as time goes by, this function fx or ft, yeah, it approaches zero. Okay, now, so that we have real zero and fake zero. Okay, so limit x go to infinity 1 over x. Okay, for example. Okay, that approaches zero. Okay, so we can call that infinitesimality 1 over infinity. Okay, or infinity to minus 1. Okay, and there are other kinds of infinitesimality too, like 1 over ln x, ln infinity. 1 over ln infinity. You have 1 over e to the infinity. Okay, yeah, all different kinds of infinitesimality. All right, just there are all different kinds of infinity. Okay, um, let me turn on the heater and grab the blanket and the whole 9 yards. Put the coat on and oh boy. Yeah, I vacuum the floor. Okay, it's so therapeutic. It just feels so clean. Cleaning, house cleaning is very therapeutic because it just feels so clean. You have to know this, okay? You wanna keep your surrounding nice and clean, okay? Because it does affect your mentality, your spirituality, okay? The physical universe and metaphysical universe is kind of mirror reflection, okay? you have to be clean and not smell bad. You should smell good, clean look, okay? And you keep your house, your car clean and well organized because your mentality, your spirituality, and your physical surrounding and your metaphysical composition is a mirror reflection. Okay, so you wanna keep your house clean and okay, it's important. Then you'll be mentally healthy. Okay, so I mean it's not sufficient condition per se, but it's necessary condition. Okay, so all right. I don't know where to begin, dude, because I guess we can start by me going to the bathroom. You just stare at this and think about it, okay? Yeah, I go to the restroom real quick, okay? And okay, I guess that's the best starting point. Me going to the restroom, taking a restroom break. Oh boy. So, so did you stare at what I wrote here and Think about it. That was the assignment. If not, that's fine too. You won't be able to read my handwriting anyway. Okay, so 0 is a constant and infinitesimality is kind of fake 0, and also it's a variable. Infinitesimality is a variable. It's a function, it's a variable, as opposed to 0 is a constant. So here, in a function, traditionally, constant is something very inferior. Inferior. Okay? Constant is, oh, we can ignore the constant. It's the variable that's more like this protagonist, the main actor in a theater, right? You have a what star, guest star, the main character, right? And then you have supporting roles. Oh, that's constants. Constants are more like it's not number one. It's like number 5, extra or some supporting role. It's not the main character. It's variable that's the main character in any function, right? There are two exceptions. Okay. One of them is 0. 0 is a constant, but it's more powerful than variables. And there's another exception. What is it? That's what we call absolute infinity. Okay, that's 1 over 0. Okay, it's a constant. I'll show you. I'll share it with you. We're just doing gradually, one by one, because this is something new. Okay? And we should be very, very grateful to God to give it to us. Okay? 1 over 0, that's infinity constant or absolute infinity. Okay? We are very grateful to God, okay, and to give that to us. So 0 is a constant, and also absolute infinity, 1 over 0, that's also constant, okay, and it's no longer variable, okay. Yeah, there is some infinite variable like infinity, or e to the infinity, ln infinity. They are infinity as variables, infinity as functions, okay. It's approaching the infinity, but it's not the absolute infinity, okay. Just like in analogy to 0, okay. Yeah, it's a major breakthrough, okay. So it's a major breakthrough, but of course we are only beginning, okay. We are just giving a brand, making a brand new algebra, infinite algebra, and we don't have to finish it. Other people can continue to develop that brand new area in mathematics, okay. Well, it's not too new. Various people have tried, like Georg Cantor, big O notation people, and one of them I learned is Donald Knuth of Stanford University. Yeah, he's a computer science professor. Yeah, I guess he contributed somewhat to that big O notation. I don't know who came up with the big O notation first. Let's look it up. Big O notation. Who studied all that? Give me 1 second. I'm gonna look up big O notation, okay? Because I'm kind of curious who came up with that, who invented that big O notation. I show you what big O notation is, okay? I share it with you. Okay, big O notation. There's a small O notation, but small O notation is not very widely used. It's mostly big O notation. Okay. So who came up with big O notation? So basically, this infinity algebra is combination of three things: big O notation and calculus, like limit, LIM, limit, in calculus, okay, and also big O notation in computer science, and also Gauss contour in set theory, okay. So we're combining the three, okay. That's infinite algebra. Okay. Paul Bachmann and Edmund Landau. Landau, I think he's a physicist too. I mean, that kind of sounds familiar. Maybe he's related to this physicist Landau. Okay, he's a Jewish guy. Yeah, he's a German Jew. Okay. Landau. Where did I heard this name? I think there's this physicist named Landau. I think that's what why it kind of rings the bell. Landau. Landau. Yeah, Lev Landau. Maybe they're not quite related. That guy's Russian. He's Soviet physicist. Yeah, he's very, very. That's why I recognize the name. But it looks like they are not related because this guy Landau, I heard his name mentioned in the textbook of physics when I was in high school in South Korea. Okay. Yeah, in quantum physics, that kind of stuff. So yeah, Landau, yeah, he's a Soviet um, physicist, and then this. Yes, this mugshot. Physicist, physicist, Soviet Lev Landau was arrested for, I mean, just reading off of Wikipedia, comparing Stalinism to Nazism. So he went to prison. It's kind of funny. He's kind of like smiling a little bit. Colorful kind of character. This conversation between Landau and a psychiatrist. Oh, this hilarious. He was an atheist. He made some jokes about Christianity, so that's quite funny. Okay, that's Landau, and the big O notation was invented by somebody else, some some other Landau. What? Leopold Landau? Okay, and another guy, the other guy, Paul Bachmann. I've never heard this guy. Or Edmund Landau. Okay, Edmund Landau. I have never heard of these guys. They are both German mathematicians. So yeah, big O notation came from German mathematicians. Okay, that's good enough. Okay, what is big O notation? I'll tell you. It's kind of hazy because I learned this such a long time ago. Um, I have to go back to Wikipedia to refresh in my memory. Okay, big O notation. Oh boy. Yeah, please bear with me. I'm just reading this big notation Wikipedia article. So it was Bachmann who first came up with the big notation, and then Landau, Edmund Landau, adopted that. And Hardy and Little, they tried to mess with it, but they tried to use omega symbol instead, but it didn't quite take off. So okay. Later on, this Donald Knuth, I guess he just kind of studied that, but he didn't quite originate that concept of big O notation. Yeah. Okay. Okay. So, uh, let's take a break, okay? But before we take a break, is this, okay? The absolute zero, the true zero, constant zero, is like this horizontal line where the uh, slope, the first derivative, slope, yeah, y is equal to x, right? That's the slope is number one, right? Horizontal line is slope zero. How about this vertical line? Okay, the slope of the vertical line, that's the absolute infinity. Okay, so that's the definition of this absolute infinity as a constant. Just like horizontal line, slope of that is true zero, constant. It's not some infinitesimality. No, it's truly zero. Flat. But if it is vertical, the slope, the derivative of that, we're gonna call that as absolute infinity or constant infinity. Okay? Yeah. So that's the definition. Okay. And we call it one over zero. Why? We'll see. Okay. Okay. So yeah, this is a very exciting field of mathematics, and Feels brand new. Okay, and we are dealing with the infinity. Okay, so we're gonna take a break and we'll unravel this concept, this entangled concept one by one. Okay. Before you do that, I'm gonna switch out the board because I guess by now you've been staring at this for a while. So we're gonna switch out. I'll take a picture, of course. You know, my cell phone is so cheap, it doesn't zoom in and zoom out or zoom out. Yeah, I can download an app, but my cell phone is very cheap, so it doesn't have much memory. Okay, so I'm gonna switch out the board and then we'll take a break. Okay, so that you can stare at what I wrote on the other board. Okay. Ah. It's like Indiana Jones or Enigma, kind of this archaic archaeology exploration, deciphering, you know, decoding. Okay, I'll leave you with this, and we'll take a break and we get back to whatever. Okay. All right. All right. Well, I've been drinking this brand new mushroom drinks, and it's kind of getting old already. So I'm getting some berry drinks. It's good, but I want to diversify my drinking menu. That's all. So what do we have here? I wrote down so many things. So there's no more room to write on. It kind of written very small and faint. But I explain it to you, okay? I explain it, okay? So just follow along, right? Take my lead, okay? I'll go nice and slow. So this infinity constant, okay, the true infinity or natural infinity, okay, is the slope of this vertical line, okay, which is bigger than e to the x exponential function. Exponential function goes like this. Polynomial function is smaller than that, right? Exponential function always win in the end by the L'Hopital theorem, okay? Because polynomials, if you differentiate again and again and again, it becomes zero, okay? But exponential function, it stays exponential function multiplied by what? ln a logarithm natural of a to the x. Yeah, you differentiate that, then yeah, ln a times a to the x. Okay, so no matter how many times you differentiate this exponential function, it stays exponential function. So exponential function always wins. Okay? It always defeats higher degree polynomials. Because polynomials, if you, by L'Hopital's rule, if you differentiate again and again, it becomes zero eventually. Okay? So yeah, if this exponential function always wins. Exponential growth, like geometric growth, something very powerful. But compared to this vertical line, it's nothing. It's smaller than that. Exponential function, no matter how steep it may be, it goes like this, you know. But the vertical line, that's the true infinity itself. It's a constant. And it's bigger than any fake infinity. Okay, the true infinity wannabes, the functions, variables. Okay, so just like zero, true zero, constant zero, it defeats all the infinitesimalities. The true infinity, the infinity constant, it defeats all the functions, all the variables, all the true infinity wannabes. Okay, it's a constant. Slope of this vertical line. Okay, that's the definition of true and absolute infinity. Constant. Constant. Okay? That's what all this garbage mumbo jumbo is about. Okay, so yeah, you don't need to think about anything else. All right, so yeah, this infinity constant is the biggest infinity. Okay, I try to come up with a nice notation. We can have infinity dot dot or infinity top infinity, but no, we call it just infinity dot dot. Okay. because uh, infinity top infinity, no, that's something else. Okay, so we just call it infinity dot dot. Okay, this constant infinity, absolute infinity. Okay. If you wanna come up with a brand new notation, go ahead. Okay, maybe you are more creative than I am. Yeah, go ahead. Come up with a new notation. Okay. Okay, well, we have to erase something, right? We have to erase something, so we're gonna uh, we're gonna erase one half of this old whiteboard. Okay, well, it's time to move on. It's been already 45 minutes. Yeah, we're gonna move on. Okay, so all right, so it's like this. Okay, the you have okay. I'm kind of peeping this earlier note that I made last night. Okay, man, this pen is really fading. Okay, do I have some new pens? Uh, let's see. It's kind of still hazy, but fadey. This is the function. You have X and Y, okay? Oh my goodness. It's time to buy a new set of pens. This is Y is equal to 1 over X, okay? Okay? Y is equal to 1 over X. Uh, let's try this pen. And here is 0, okay? My goodness, it's worse. How about orange? Here you go to 0 plus, okay? From here you go to 0 minus, all right? Yeah, okay? You approach 0 from the right, you approach 0 from the left, okay? Now, limit of this function 1 over x when x is approaching plus 0, okay? And that's 1 over 0, and that's the definition of this infinity, absolute infinity, infinity dot dot. Okay? That's that. Alright? One funny thing is this. Yeah, we'll do the slope, kind of like differentiation definition later, okay? Because I haven't quite thought about that yet. How do we different? How do we define this infinity constant in terms of slope? Okay, we'll do that later. All right. I haven't thought about that yet. Okay, so that's the intuitive definition of this 1 over 0 as an absolute constant infinity. The infinity that's the biggest, the maximum possible infinity. Okay, vertical line. All right, because y is equal to y is equal to 1 over x. It's like goes like this. It's become very very infinity. Vertical. It's not like this y is equal to e to the x. y is equal to minus e to the x, to compare. It goes like that, right? So yeah, it doesn't have quite have this wall exponential function. Yeah, it doesn't have this brick wall exponential function. It's just kind of like diagonal, diagonal. Exponential function is kind of diagonal, okay? But y is equal to 1 over x, or y is equal to 1 over x squared, whatever, okay? It hits the brick wall. So yeah, it goes to the infinity faster than exponential functions, okay? So that's that. All right. I know it's a lot, or maybe it's not, okay? But I want you to think, okay? So we're gonna take a break. I will start cooking my dinner, and we'll get back to whatever, okay? All right. Yeah, keep thinking, okay? Okay, we're back. I need you to think independently because who knows, I may make some errors like I have many times. Okay? Yeah, correct me if I'm erring. Okay? So, okay, we're gonna have some fun, okay? Mathematical fun. Geeky, nerdy, gooky, cookie fun, okay? It's like this. I'm still copying from this stuff. You have a line, a straight line, okay? We can call it ax plus by plus c is equal to 0. By, okay? And all we know is this. I'm kind of getting cold. Okay? Let me take some cold medicine because it's really bothering me. By the way, I did plenty of exercises before this recording because of some time left. I was moving over some files. Each of this episode, like 3 hours long, is like 10 gigabytes, man. So I have to use external storage and whatnot. Okay, so, whew. Yeah, turn up the heater so it will get warm pretty soon. So okay, for all we know, it passes this dot 1, 1, okay, and it also passes this dot. It's a straight line. So this is 1, 1. It also passes what 0, 1, right? So let's plug that in to find out what is. By the way, we have to use ax plus b plus c because this a, it can be 0, and traditionally we cannot divide by 0, right? But later on we will be able to, okay, because we're going to define brand new rules, okay, how to divide things by 0, okay. So it's going to all change later on, but for now, okay. Okay, 0, 1, plug it in. So what, b plus c is equal to 0. 1, 1, okay, a plus b plus c equal to 0. Now b plus c is 0, so a is equal to 0, okay. Now you have by minus b equal to 0, okay. So y is equal to 1. I mean, unless it's a straight line, okay, unless b is also 0, but assuming b is not equal to 0, yeah, it's just that, okay? Because, okay, by is equal to b, okay? Then let's have one more point here, okay? 2, 2 comma 1, okay? So when x is 2, y is 1, okay? We don't have an x anymore, so b times 1 is equal to b. Yeah, you know, it's kind of tricky, okay? It doesn't say anything about b, okay? So actually b can be actually 0, or 1, or 2, or 3. B can be anything, okay? So it's very, very tricky concept we are dealing with here, okay? But what if we come up with a brand new way to think about this, to solve this problem ax plus by plus c equals 0, okay? Okay, you have 1 comma 1, right? You pass through 1 comma 1 right here. So a plus b plus c is equal to 0, okay? How about this? Far away here, the star, remote star, is its coordinate is infinity, comma 1, okay? X go to infinity, okay? And y is still 1, okay? Let's plug that in, just for fun, okay? Now a times a, infinity plus b plus c is equal to 0, okay? And a times infinity, b plus c is equal to minus a, right? So now you have a times infinity, and it absorbs minus a, right? Because it's infinity, right? It's equal to 0, okay? So what is a? Is equal to 0 over infinity, which is equal to, this is true 0, okay? Infinity is a variable, okay? So it's like 0 multiplied by 1 over infinity is equal to 0 times 1 over infinity which is kind of like 0, okay? It's infinitesimality, okay? It's like 0, it's a one kind of infinitesimality, but through 0 it absorbs that, so we can call it 0 dot is equal to 0. So a is 0, okay? Alright, if a is 0, b is equal to minus c, okay? So a is 0, so by, and what is c? A is 0, c is minus b, okay? Minus b is equal to 0. So by is equal to b, okay? So something like y is equal to 1. So I'm just demonstrating it to you. We can use this brand new dot, like star dot, okay, infinity comma 1, to solve an equation, okay? That's the whole point of discussing this, okay? Yeah, still have to sort out many things, so I'm gonna take a picture of this and zoom it in for you, okay? It's a brand new way to solve an equation. Well, my phone is charging, so let me bring back my phone, because my phone is it has enough juice in there, okay? So take a picture and zoom it in for you, then I will erase. Okay. 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 That's good. Ah. Oh, I'm sorry. I forgot to zoom it in. But you can see it. I mean, it's not. Yeah, it's orange color, but you still were able to see it. Okay. So, yeah, I don't feel too bad. I come. It's easy stuff. I can read it to you too. So, shouldn't be too much of a damage that I erased before I zoomed in for you. Yeah. I'm sorry. Okay, I apologize. All right. All right. So what do we do now? Um, we can take a shot at defining this absolute infinity in terms of the slope. Okay, the slope of a line. Okay, it's like this. Okay, oh boy. Conceptually, it's like look like cross, right? So the joke of this Lev Landau guy, he got into car accident, have some brain injury, so his psychiatrist, neurologist was testing him. Hey, draw a circle, and he drew a circle, and draw a cross, and he drew a circle. And psychiatrist was like, neurologist, well, brain surgeon, I don't know. Yeah, why are you drawing a circle? I told you to draw a cross, and he said, oh, because I don't want to look retarded. Okay, so he's very, very atheistic, anti-Christian kind of guy. Okay, whatever. Okay, it's not a cross. It looks like cross. Maybe it is. Okay, stepping stone, whatever. But it's XY coordinate or Cartesian coordinate, right? So you have this. What y is equal to x, right? And here the x-axis is what? X equal to I'm sorry. Y is equal to 0. Y is equal to 0. Now your vertical axis, y-axis, it is defined as x is equal to 0. Okay? So, and in between you have this whole y is equal to 2x, y is equal to 1 half x, all that shit. Okay? But in the extreme you have x equal to 0, y is equal to 0. It's a constant function. Okay? And that's the intuition behind this concept where absolute 0 is also is a constant and absolute infinity is also a constant. Okay? And that's the biggest infinity. Okay? All other infinities, like, you know, limit x go to infinity of x or ln infinity e to the infinity, that's just wannabes. Okay? The biggest infinity is actually a constant. Just like the smallest 0 is a constant. All this infinitesimality, like 1 over ln x, 1 over e to the x, when x go to infinity, that's just wannabes. imitators, fakes. Infinitesimality is not even never become the true zero. Okay? There's this symmetry, all right? Infinity, it works the same way because they are kind of inverse function. Inverse function to each other, you switch y and x, okay? X equals 0, y equals 0, you switch x and y. The inverse function of each other is kind of like mirror reflection along this diagonal line, y is equal to x, okay? We had some problem with that, right? So actually that's how I was able to discover this infinity constant, okay? Because the original initial motivation is that limit f over g by the L'Hopital theorem is equal to limit f. I'm sorry. I mean second L'Hopital theorem. Okay, limit g inverse. Okay, over f inverse. But what if f is a constant? What is limit 1 over x? Okay, is equal to, if you use the second L'Hopital theorem, inverse of 1, this constant function, okay? What the hell is that? Y is equal to 1. What the hell is that? This is x is equal to 1. Then how do we define it in terms of y? It turns out to be the absolute infinity, okay? And what is inverse of x? It's just x, right? And this becomes 0. Okay, why? Because absolute infinity is bigger than any infinity. So this becomes what? Infinity dot dot go downstairs, and over there you have first order infinity, right? This is true 0. Okay, so that's that. Okay, so that was the initial motivation. I know I'm kind of being very sketchy. Okay, we organize this later. We're still brainstorming, right? So okay, so let's take a shot at defining this absolute infinity in terms of slope. Okay, so I haven't gone that far yet. Okay, all right. So y is equal to ax. Okay, let's assume a is a positive number. All right. So dy dx is equal to a, right? Okay. What if dy is 0? That is easy, okay? 0 over dx dy delta y is 0 because it's like horizontal line. Yeah, is equal to 0 is equal to a. Okay? But what if this vertical line, that's where you have dy. Yeah, y can move over up and down. This delta y, change in y. Okay? But x is not increasing or decreasing. So dx is 0. That's what a is. The slope of this vertical line. That's what a is. And we will call this infinity dot dot just for now, okay? Yeah, it kind of looks like bikini, whatever, okay? We call it infinity dot dot, alright? Infinity constant. The biggest infinity ever, okay? slope of the vertical line. Okay, so we got it. Okay, we got it. Now, the very funny thing about this, okay? So there is a y is equal to x, y is equal to 2x, y is equal to 1/2 x, okay? But when slope is negative, okay? And go negative, 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 then it still become vertical line in the opposite direction. But they look the same. Positive infinity, negative infinity, they look the same. It's just vertical, one vertical line. It's very circular, you know. You know, opposite attracts each other. Okay, whatever. So how do you explain that? Oh, it's so easy. Why? Because this is true zero. So if you multiply this zero by -1, like let's say minus dy, this minus can go downstairs. So -1 times 0 is 0, right? That's why infinity dot dot, it has no polarity. It's like God. God loves both good people and bad people. That's what Jesus said, right? Yeah. God has no polarity. He's so inclusive, very liberal. Okay? So he loved, not exactly liberal, because liberals, they hate conservatives. Conservatives, they hate liberals. God, like infinity, true infinity constant. God, you know, he's constant, he never changes. God is always the same, right? So yeah, God. Yeah, infinity mathematics is kind of like theology. Okay? God is still the same. You know, he doesn't change, right? I mean, that's kind of Christian theme. Yeah, God is always loving. He's always good. Okay. God loves both liberals and conservatives. So very inclusive. Okay. So he has no polarity. He's not God is not conservative or liberal. He's both, and also he's neither. It's just neutral. Okay. So it's very inclusive kind of diversity God. Okay. So we have that. Okay. Now is positive infinity slope, negative infinity slope. It looks the same. It's just one vertical line that goes into either direction. Okay. Because -1 times 0 is 0, plus 1 times 0 is also 0. Okay. The polarity, the signs, it just disappears. Okay. So this infinity algebra is very, very theological and also very philosophical. Okay. Probably that's why they haven't quite got it yet until today. Okay, you are witnessing, you are participating history making. Okay, this is something very big if you realize that. Yeah, yeah, but we got it. Okay. We're gonna take a break. Okay, then we're gonna switch the gear. We'll stay focused in this infinity algebra, but we're gonna switch out the board. Okay, so why don't you stare at it and think about it? Okay, we take a break. We switch out the board, and then we just keep moving back and forth. Okay. All right. Very interesting. Okay, we're back. Night is still young, spring in kind of springtime in Alaska, so we got long daylights. Okay. Oh yeah, I gotta switch out this board. Yeah, it's nice and warm nowadays. Ah, okay. All right. Okay. So, what do we got here? We can erase all this. We're gonna erase everything, okay? Because we already went over this, okay? So, okay. Now it's kind of getting warm because house is been warming. I can turn off the heater. I take this vitamin D3 because I live in Alaska. We don't get enough sunshine during the winter. And they came up with this great American invention, the vitamin gummy. Ooh, so good because it's just pill. I don't want to take the pill, vitamin pill, but multivitamin gummy. Ooh, so good. Americans are so ingenious. They're very inventive people. Okay. Yeah, it's good to be an American. Oh boy. I love Americans, by the way. You guys are cool. Alright? So, okay. Let's keep moving on. Let's do big O notation, okay? Big O notation is this. Big O notation of x 3 times x to the third plus 2 times to the x to the second blah 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 is equals same is equal to big O of x to the third. Okay? It is just it's our predecessor. Our predecessor to our it's one of three predecessors of this infinity algebra because it ignores all the lower terms and all the constants. It extracts what matters the most. Okay, that's the power of big O notation. Okay. Yeah, if x go to infinity, okay. Yeah, lower terms, yeah, ignore it. Constants, ignore it. Okay. So that's that. Okay. And I learned this when I was majoring computer science in college. Okay, and it's something very very powerful, and very very easy and simple. That's what makes it so powerful because it's so easy. It simplifies things dramatically. Okay, no bullshit. Okay, just extract what matters the most in the eventuality. That's big O notation. There's a mathematical philosophy behind the big O notation. Okay. Okay. That's what we are all gonna say about big O notation because we got a lot to do. Okay, so you wanna learn more about big O notation? Look it up. All right, just catch up. All right, because yes, let's say one more thing about big O notation. Okay, it in computer science, it's about they call it complexity of an algorithm. Okay, but it's misnomer. It's about how much time does this algorithm takes? Is it an efficient algorithm or very slow, inefficient algorithm. Okay, because it come up with same solution like sorting algorithm. It could be big O of n squared or big O of n log n. Okay, like Dijkstra's algorithm, whatever. Okay, but yeah, same sorting algorithm. I mean, it gives a you have A B C D E F G, right? What if the input is D E F B C A? Yeah, you have to sort it in alphabetical order, and there are many a slew of sorting algorithms out there. There's bin sorting, Dijkstra sorting, whatever. Okay, merge sort invented by John von Neumann. Yeah, slew of so many different sorting algorithms, ingenious. Okay, like by mathematicians, computer programmers, computer scientists. Yeah, all they are great, but some algorithms are more efficient than other algorithms. Okay, so that's how big O notation is used. Okay, they call it complexity, but they better call it efficiency. Okay, okay, yeah. So efficiency of algorithm. Okay, some algorithm computer programming depending on who wrote it. It's more efficient. It's faster than other computer programming, but it give out the same result. But some programmers are smarter than other programmers, so they come up with faster calculating computing algorithms. Okay, some algorithms are slow, some algorithms are faster. That's the efficiency of computer algorithm. Okay. Oh my goodness, I'm exposing my bald spot right here. Whatever. Whatever. Okay. Okay. Now let us step back and think about this infinity algebra. Okay. It's fascinating. Okay. So you have 0 over 1, okay, and 0 over 0, okay, and you have 1 over 0, okay. And curious, curiously enough, there, when I learned about this in South Korea in high school, they have this mnemonics, okay, because this 1 over 0 is a Korean alphabet. It corresponds to H, okay. This 0 over 1 is a Korean word. It is pronounced as woo, boo, woo, whatever, okay. And this 0 over 0 is also a Korean combination of Korean characters, okay. It's pronounced as okay. Some kind of curious coincidence, okay. Anyway, a single consonant character, consonant, vowel, vowel. I mean, woo. This is vowel together. Consonant, vowel, consonant. Okay. Very curious. Interesting. Yeah, but that's not important. Okay. It's just linguistics peculiar to Korean language. Okay. We go get back to mathematics. Okay. So 1 over 0, okay, is infinity constant. 0 over 1 is 0 constant. True 0. Then what is 0 over 0? It's not a single number, but it's a set of every single number in the universe, including infinities and infinitesimalities and constants. You have variable numbers like infinities and infinitesimalities, and you have constant numbers like 1, 2, 3, square root of 2, whatever. Okay. 0 over 0 is not a single number, but it's a set of all numbers in the universe. That's what 0 over 0 is. Okay. Why? It's because of this. 1 times 0 is equal to 2 times 0. Okay? You pass it over. 1 over 2 is equal to 0 over 0, right? Why? Because this guy, 0 over 0, it absorbs everything. It can equalize everything. It includes everything. 0 over 0 is not one number. It's set of all numbers. Okay? So it's not one number, but it's set of all numbers in the universe, including imaginary number, including infinitesimalities, including these variable infinities. Yeah, it includes everything. Okay? So that's what it is. Now, 0 over 1, that's true 0, absolute 0. 1 over 0 is true absolute infinity, constant. These guys are constants. This 1 over 0 and 0 over 1, they are constants. But 0 over 0 is a set. Okay? So that's what it is. So in this absolute infinity, okay, it's vertical line, and absolute 0 is a horizontal line. Okay? You multiply by this, multiply through 0 by infinity or e to the infinity, which is variable infinity function, yeah, it absorbs it. Absolute infinity is equally absorptive as true 0. True infinity, it also absorbs everything. Okay? Minus 1 plus 1 minus x plus x minus e to the x plus e to the x. Yeah, it absorbs everything because you're at 0 downstairs. Because if you multiply by e to the x, okay, you multiply by e to the x, right? Same as you multiply by 1 over e to the x downstairs. Okay? This is same as multiplying upstairs e to the x. Okay? Yeah, it all becomes, it absorbs everything. Okay? No matter what it is. Because you have 0 downstairs. Okay? Yeah. So 0 is a very, very single most powerful constant, or even most powerful number there is. It absorbs everything. Okay? When it is multiplied. But when it is added upon, like 0 plus 1, now it collapses. Okay, that's the weakness of 0. Zero is very powerful in terms of multiplication, but not in terms of addition. Okay? That's the symmetric duality between zero and infinity. Why? Because infinity, if you remember, infinity plus one is infinity, right? So infinity absorbs everything when it comes to addition. Okay? But zero absorbs everything in terms of multiplication. But if you start to add something or subtract something, zero disappears. It's that addition. 0 plus 5 is 5. Okay, so 0 disappears, evaporates, vanishes. Okay, that's the vulnerability, like blind spot of 0. 0 is so vulnerable in terms of this basic, very basic arithmetic operator, plus or minus. Okay, 0 plus 5 is 5. 0 disappears. 0 minus 5 is minus 5. Okay, so 0 disappears. But when it comes to higher or step higher operator, yeah, 0 times 5 is 0. 0 absorbs 5. 5 disappears. 0 through 0 times infinity in the fourth degree, yeah, it's still 0. Okay? So, yeah, okay. 0 times infinity, the fourth degree infinity, okay, is equal to 0 times infinity squared is equal to 0 times e to the infinity is 0. So in terms of in the world of multiplication, 0 is the king. It absorbs everything. I hey you can run, but you cannot hide. Okay, I kill you all. I conquer you all. I'm the king. You're all subjects of mine. So in the multiplication land, 0 is the king. Okay, but in addition land, infinity is the king. Okay. Infinity absorbs all the other things when it comes to addition. Okay? For example, this infinity squared plus infinity plus is equal to infinity squared. Okay? Infinity to the first, like limit of x when x goes to infinity. That's what infinity to the first is. Okay, and infinity squared plus what ln infinity, yeah, or just infinity plus ln infinity is just it absorbs. Okay, using the L'Hopital's rule. All right. Yeah, in the plus land, yeah, infinity is the king. Okay? But in multiplication land, 0 is the king. It absorbs everything. Okay? So, now, I know it's a lot. Okay? Yeah, it took me a while to grasp this brand new idea. Okay, so we're gonna take a break, okay? And then you take a look at this, think about it, and if I'm wrong, yeah, correct me, okay? I'm getting real hungry now. But we take a break and we get back to whatever, okay? Alright. Okay, we are back. You know, I'd rather finish this episode early so that I can have some time to dance because all this after all these recordings, it's like I'm just too tired and I gotta eat, sleep, go to work next morning. That's been this week, whole week. But tonight, yeah, I wanted to learn. I mean, do dance along this music to the hustle. I love that music, man. McCoy, Van McCoy, he's so good. Anyways, okay, so yeah, we're gonna examine some absorption rules in this infinity algebra. Okay, so okay, then I'm finished this recording. I promise. Then I want to dance. Okay, so I want to celebrate. It's brand new breaking ground, whatever, groundbreaking discovery. Okay, so you have zero. Okay, and you have infinitesimality, which is an element of a set of infinitesimalities, okay, that includes, it's kind of fading, so 1 over infinity, 1 over infinity squared, 1 over e to the infinity, 1 over ln infinity, whatever, okay? Blah, 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 okay? It's infinitesimality. Just one element of it is set of all infinitesimalities. It's a fake zero. Zero wannabes, okay? So that's that, okay? This is true zero, like 0, 0, okay? Now, downstairs we have something kind of mirror image of that, okay? We have absolute infinity, okay? Infinity dot dot is equal to 1 over true 0, true 1, true 0, okay? And then we have infinity dot, which is an element of this box infinity, which is a set of all the infinity. Infinity, you have infinity to squared, e to the infinity, or ln infinity, blah blah blah. Okay, we have that. Okay, zero dot is a variable, and infinity dot is also a variable. Okay, it's fake infinity, fake zero. Okay, so asymptotic. It constantly approaches zero, constantly approaches infinity, true infinity, constantly approaches true zero. Okay, that's what it is. Okay. You got it? No. I mean, I'm not gonna take a picture. Yeah, I'll take a picture of this. Okay. Eh, it's kind of important concept. So yeah, let me take a picture of this. Okay. All right. Ugh. Okay, that's good enough. Now we're gonna examine some absorption rule. You have zero, fake zero, true infinity, fake infinity, okay? And let's examine some rules, absorption rules. Because true zero and true infinity they are constants. Okay? True infinity and true zeros, true zero, true infinity they are constants. Okay, so 0 times x is always 0. Okay, this x can be a constant, it could be infinity variable, it could be infinitesimal variable, whatever. It absorbs everything. Okay, now how about infinity constant multiplied by x? What if we multiply true zero and infinity constant? What would that be? Big question mark. Okay? Well, it's too easy, right? What is infinity? What is infinity constant? It's 1 over 0. So it becomes 0 over 0, which is equal to set of all numbers. Constant, special constant, multiplied by the other special constant, okay? It gives birth to set of all numbers. Okay? It's something very magical, alright? Yeah, this is just infinity constant, okay? As long as x is not true infinity. Here, as long as x is not true zero, okay, then yeah, it absorbs everything. Okay. Because what is this? 1 over 0, right? You multiply by some number a is equal to 1 over 0 times 1 over a. It just absorbs everything. Is equal to 1 over 0 is equal to true infinity, okay? Yeah, that's that. Okay. But be aware, in infinity algebra, associativity does not apply. The rule of associativity, like a plus b plus c, a plus b parenthesis is equal to a plus b plus c parenthesis, that does not hold true. Okay, so infinity algebra is unique and singular in that associativity rule does not apply. Okay, we talked about this before. Okay, so we're gonna finish up right here. Okay, and then I really have to dance with this music because it's been playing in my head for a while. It's like screaming at me. Okay, so I'm gonna dance the hustle. Okay, this Van McCoy, fantastic music. Oh, I'm not. I'm tired. I'd rather just eat. Okay. Yeah. Dancing maybe tomorrow. Okay, but tomorrow is Friday. Then Saturday, Sunday. I can dance on the weekends because dancing on the weekdays is just too much in my age. At my age, oh, I don't think I can dance during the weekdays. Okay? But we're gonna finish it right here. Okay. Alright, thank you. Good night. Bye.